Okay, this is the modulus function. The modulus function is written as an x or something between two vertical lines. So it's not a bracket, it is a modulus bracket, if you like. And what it does is it takes the sign of x and ignores it. So if it's negative, it will turn to its positive value, but if it's positive, it just remains as it is. So mod of 5 is 5, mod of 7 is 7, mod of pi is pi, but mod of minus 2 is 2, mod of minus 12 is 12, etc. A couple of ways to define it. We could say it's equal to the positive square root of x squared. Yeah, for real numbers, this is a good definition. Or we could say it's equal to x such that x is greater than or equal to 0 and negative x when x is less than 0. Okay, so this is what's called a piecewise definition. It's written in pieces. So what does the graph of this look like? Well, when x is positive, it just remains x, so y equals x when x is positive. When x is negative, however, it takes negative x. So when it's minus 1, it's actually minus minus 1, which is 1. When it's minus 3, it's actually minus minus 3, which is 3. So it just takes that line and reflects it in the x-axis. So that's the graph of the modulus function. And it's above the course spec, but just in case you're interested, the derivative of this, dy by dx, is equal to minus 1 for x is less than 0, undefined for x equals 0, and positive 1 for x greater than 0. Again, that's a piecewise definition, and that is a type of step function. It's got an infinite gradient between minus 1 and 1. And the gradient would look, the graph would look something like this. There'll be a hollow hole there, it'll carry on. Type of step function. So modulus function, well, how does it affect our graphs? Well, let's say we've got the graph y equals f of x, and it looks something like that. Just some kind of generic graph. There's my x. There's my f of x. Okay, so there's no mods in there at the moment. Well, what happens if we start to apply mods to that graph? For example, what does the graph of y equals f of mod x looks like? Well, for when x is greater than 0, this is just going to be f of x. Because part of our definition of the modulus function is that when when x is greater than 0, y just equals x. So when x is greater than 0, x just equals x. So it's going to look exactly the same for positive x values. So it's going to have the turning point on the axis, it's going to go below the x-axis there, it's going to go up, and it's going to scribble. It's going to look exactly the same. But for negative x values, this is actually going to not look like this bit at all. And actually this bit just gets completely ignored. There's no way to get f of a negative value in here anymore because this content is always positive. So this part of the graph is never seen on this function. And what actually happens is what's in the positive x direction here gets reflected in the y-axis. So it becomes what's called an even function. Because f of minus 1 is the same as f of 1. F of minus 5 is the same as 5, etc. And that applies to any graph. Okay, if you take the x and you mod it in the definition of f, then the negative gets ignored, and whatever's in the positive gets reflected in the y-axis. The other thing that we can do is we can take the whole of f and mod it. So mod of f of x. So subtly different to the f of mod of x. This is mod of f of x. And what happens here is that nothing of f can be negative. So those bits of f that were below the x-axis, they can no longer be below the x-axis, because this is always going to be a positive number for y. Y will always be positive. And in fact, whenever f is negative, then the mod of the f will just make it positive. So anything that is above the x-axis remains above the x-axis because it's already positive, but anything that's below the x-axis will be reflected in the x-axis, and so we'll end up with a number of points which have a discontinuous gradient, which is very normal for graphs of this form. So anything above the x-axis will remain above the x-axis. So that'll still look like that. That'll still look like that. Oh, yep. But this bit here will be reflected in the x-axis. So it won't go down here, it will go up here. And this bit here won't go below the x-axis. Instead, it will go above and it will look like that. Okay, and that's the graph of y equals mod of f of x. X, y, x, y. Thank you for watching.